Hi everybody. So in this video, we're going to look at using differentiation to find the gradient at any point along a curve. So we're going to work through two examples and then we'll try two exam style questions. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So in our first example, we've been given the curve with this equation and we've been asked to work out dy by dx. So this is when we differentiate x squared minus 6x plus 15 with respect to x. So we'll say dy by dx. To differentiate x squared, we'll multiply the 1x by the power of 2, and then we'll take away 1 from this power, so we get 2x. We'll do the same with the negative 6x. This is x to the 1. We'll multiply the 1 by the 6, we get negative 6, and then we take away 1 from this power, so we get negative 6x to the 0, and x to the 0 is just 1. So this becomes 2x minus 6. And when we differentiate the 15, well, this is 15x to the 0, because x to the 0 is 1. When we multiply the power 0 by the 15, we get 0. So this constant of 15 term will just go. So we're left with dy by dx is equal to 2x minus 6. And this is the gradient function of this curve. What this means is, if we wanted to work out the gradient at any point along this curve, we just substitute the x value into our gradient function, and that will tell us the gradient. So for part B, find the gradient at the point 0, 15. Well, this is when x equals 0. So if we substitute x equals 0 into our gradient function, dy by dx, we'll get 2 lots of 0 minus the 6. So our gradient will be negative 6. And that will be the gradient of this red tangent to the curve here. And then for part C, find the gradient of a point 4, 7. Well, this is when x equals 4. So we'll substitute in x equals 4 to dy by dx. We'll get 2 lots of 4 minus the 6. So 8 minus 6 will give us a gradient of positive 2. And you can see that when x is 4, the gradient is positive here. Okay? So the point of this example was to show you that we can find the gradient at any point along this curve by differentiating this with respect to x and substituting in the x value at that point. Okay? Let's try another example. Okay, for question 2, we've been given this curve with this equation, and we've been asked to work out dy by dx. So we need to differentiate each of these terms with respect to x. So dy by dx, when we differentiate with 6, we get 0. When we differentiate negative 2x, we get negative 2. When we differentiate negative x squared, we get negative 2x. So this will be negative 2 minus 2x. Okay? Part B, find the gradient at the point 1, 3. So this is when x equals 1, which is this point here. We'll substitute x equals 1 into our gradient function. So dy by dx will be negative 2 minus 2 lots of 1. And this will give us a gradient of negative 4. And you can see that the tangent is negative. And then for part C, find the coordinates of a point where the gradient is 4. So now we're told that dy by dx is equal to 4. So we'll substitute this into here, and we'll get 4 is equal to negative 2 minus 2x. So we'll move a negative 2 to the left-hand side, and then we'll divide both sides by negative 2. So x will equal negative 3. So what that tells us then is when x equals negative 3, the tangent to the curve at that point, the gradient of this will equal negative 3. Okay? Let's try some exam style questions. So in our first question, we've been given the equation y equals 2x cubed plus 3x squared plus 2. We've been asked to work out dy by dx. And then we've been asked to work out the coordinates of q when the gradient at that point is negative 1.5. So perhaps you want to try these questions yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So for part A, the first thing we'll do is we'll differentiate each of these terms with respect to x. So dy by dx, this will give us 6x squared. When we differentiate this term, we get 6x, and this constant will become 0. And then for part B, we're told that the gradient of a curve at q is negative 1.5. So dy by dx is equal to negative 1.5. We'll substitute this into here, and then we'll solve the equation for x. So negative 1.5 will equal 6x squared plus 6x. So now we just have a quadratic, which we can solve by making it equal to 0. So from this quadratic, we can solve this on our calculators. If we go to home, we'll choose equation, we'll choose polynomial, a quadratic, we'll enter the coefficient of x squared, the coefficient of x, and the constant term of 1.5. And you can see that x is equal to negative 1/2. And that's a double root, okay? So if x equals negative 1/2, we can find the y by substituting this value of x back into our equation. Now, a common mistake here is to substitute that into dy by dx, but that will give us a gradient. We want the value of y, so we'll substitute it into here. And when we work this out, we get y equals 1/4. So at q, the coordinates are negative 1/2 and positive 1/4. Okay? Let's try question 2. Again, we'll differentiate each of these with respect to x. So we get dy by dx. This will give us 12x squared. We'll differentiate with negative 8x. This will become negative 8. And this constant will just go. And we've been asked to work out the gradient at a point 2 and 21. So we'll substitute x equals 2 into dy by dx. So we'll get 12 lots of 4 minus 3/8. This will give us a gradient of 40. And then for part B, find the x coordinates of the 2 points when the gradient of a curve is 1/3. So again, dy by dx is given as 1/3. We'll substitute that in place of our gradient function here. So 1/3 will equal 12x squared minus 8. At this point, we can cancel out the division of 3 by multiplying everything by 3. So we get 1 will equal 36x squared minus 24. Then we'll bring this one to the right hand side. And this will give us minus 25. Now we can solve this by factorizing. We've got the difference of 2 squares. So we'll have 6x plus 5 multiplied by 6x minus 5. So our values of x are negative 5/6 when this bracket equals 0 and when x equals positive 5/6. Okay? We don't need to work out the y values because we were only asked for the x coordinates. So thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.